Walnut husk fly was first discovered in California in the 1920s, after accidental importation from the south-central United States. And it continues to be an unpredictable pest and an economic factor for many walnut growers. Walnut husk fly is an important pest in several major walnut growing areas. In many places it is becoming an increasing problem. Although any variety of English walnut can be attacked by husk fly, the most susceptible varieties are Eureka, Franquette, Mayette, Payne, Hartley, Sur, and Waterloo. The new variety, Tulare, is suspected of being a susceptible variety as well. Black walnuts are also a preferred host for walnut husk fly. Walnut husk fly can cause up to 100% damage if it is not controlled. It is a problem that many times can be easily controlled when growers understand the biology of walnut husk fly and follow monitoring and control guidelines. The walnut husk fly, Rhagolitis completa, has one generation per year. They overwinter as pupae in the soil at a depth of 1 to 4 inches, and generally emerge as adults from late June until mid-September in valley areas. However, in coastal areas, adults may emerge as early as mid-May. The walnut husk fly pupae found in the soil resemble grains of wheat and are straw-colored and somewhat barrel-shaped. Peak emergence is usually in mid-August. Females usually emerge first and predominate during July, while males usually predominate at the end of the emergence in September. The average lifespan of a walnut husk fly is 30 to 40 days. Adult flies are brightly colored and about the size of a housefly. They are tawny brown in color, have a yellow spot on the midsection of the body, and have iridescent blue-green eyes. A dark triangular band at the tip of the wings also helps distinguish husk fly from other flies found in the orchard. Although flies usually spend 2 to 3 weeks or more on foliage before mating, mating can take place as early as 8 days following emergence. Between emergence and mating, females must have a source of nitrogen, that is, protein, for development of eggs and egg laying. Natural sources of nitrogen found in walnut orchards include bird droppings and honeydew from aphids. Males wait on nuts to mate with females when they are ready. Males are often seen boxing and dancing. Mating and egg-laying often occur late in the flight, but varies greatly from year to year and orchard to orchard. When mating does occur, it can take up to 30 minutes. About a week after mating, females puncture the nut, usually in the upper third of the husk near the stem. There is usually no more than 1 egg-laying puncture or sting per nut. The black spot or sting is visible within 2 hours of the female fly laying eggs in the husk. However, stings are difficult to distinguish from other blemishes by the untrained eye. Female flies deposit eggs in groups of about 15 below the surface of the husk. Newly laid eggs are pearly white and darken as embryos develop. In 4 to 7 days, eggs hatch and the young, nearly transparent maggots begin to feed on the husk. The older maggots are plump, pale to bright yellow in color, with black mouth hooks. After feeding on the husk for 3 to 5 weeks, mature maggots drop to the ground and burrow into the soil to pupate. Most emerge as adults the following summer, but some remain in the soil for 2 years or more. The minimum time from first fly emergence to visible damage from larval feeding on a nut is 14 days, but it is usually much longer. Once the maggots hatch and start to grow, fluid may run down the side of the husk, forming a tear stain. This is a highly visible sign of a walnut husk fly infestation. As the maggots develop, they continue to feed inside the green husk, turning it soft and black. The outer surface of the husk usually remains intact, but its fleshy parts decay, and stain the nutshell. These stains cannot be removed by normal bleaching procedures, and the nut is therefore unsatisfactory for in-shell use. A huskfly infestation early in the season leads to shriveled and darkened kernels, and may induce mold growth. Huskfly damage may appear similar to blight and sunburn, but can be determined to be from walnut huskfly by cutting into the husks and looking for the maggots or signs of feeding damage. The husk of nuts damaged by blight or sunburn are also hard rather than soft. Late infestations do little damage to the kernels, but may stain the shells. Infestations which begin within 3 weeks of harvest or after husk split cause very little, if any, economic damage. Other fly species, such as Drosophila fruit flies, may also attack walnuts, particularly walnuts on the ground. Drosophila only attacks walnut husks which are already damaged or decaying from other causes. White, slender, and elongated maggots in husks found on the ground are Drosophila fruit fly or other fly maggots, and not the maggots of walnut husk fly. The proper use of traps and monitoring techniques is critical to effective walnut husk fly control. When properly used, traps can be economical, convenient, and effective devices which will determine when and if flies are present in the orchard, aid in estimating the size of the fly population, and help determine treatment timing. 2 types of traps have been recommended for walnut husk flies. They are the yellow sticky panel with supercharger and the green sticky ball. The yellow sticky panel with the supercharger containing ammonium carbonate is currently the most helpful trap for evaluating fly populations and aiding in determining spray needs. However, this trap is not very accurate for timing spray applications because there is no relationship between trap catch and the onset of damage. The green sticky balls mimic developing walnuts and do not begin to attract husk flies until they are ready to lay eggs and cause damage. Male flies are caught on the green sticky balls at the same time as egg laying occurs on the nut. This does not give the grower enough time to spray before damage occurs. Because of this problem, the yellow supercharged sticky panel is the recommended trap. The yellow sticky panel should have non-baited stickum and the supercharger used as the bait. The yellow sticky panels with bait, ammonium acetate, in the stickum, plus the superchargers, catch fewer flies. The recommended yellow sticky panel with no bait in the stickum and the supercharger will catch the most flies. Traps need to be maintained by removing flies, other insects and debris, and by stirring the stickum occasionally. The supercharger should be replaced every 3 weeks. The yellow sticky panel trap should be placed in the orchard before emergence begins. This is usually around mid-May in coastal areas and around July 1st in valley locations. Traps should be placed on the north side of the tree. This is where the first damage is usually detected. These traps should be placed high in the upper third of the tree canopy. Traps placed low in the tree canopy or in the sun catch few flies. Traps can be installed by tossing a rope over a high branch and using it to raise and lower the traps. A pole can also be used for placing and removing traps. The flies do not fly far and are not evenly distributed within orchards. Consequently, it is important to place more than just one in orchards for most effective trapping results. 2 traps per 10 acres should be adequate. Growers should always have their traps in known hotspots in the orchard. Hotspots are usually heavily shaded areas, damp areas, areas near black walnuts, or areas where previous damage was heavy. Traps should be monitored by removing flies and recording fly catch. This should be done at least twice per week until the first treatment is applied. Then weekly monitoring is adequate. These traps will help determine population levels and whether a treatment is needed. No numerical fly catch treatment thresholds are available. Growers can develop thresholds for their orchards by keeping records on fly numbers and damage each year. Since the time of egg laying and the onset of damage often occurs late in the flight and varies greatly from year to year and orchard to orchard, flies captured on traps should be sexed and the females should be squeezed to determine if they are full of eggs. Sexing flies and squeezing females to determine egg development will provide you with accurate spray timing information. Viewing the flies through a hand lens makes sexing flies and egg identification easy. Sexing flies and looking for eggs should be started 8 days after catching the first fly. The latest information indicates that once traps have females with eggs, growers have about a week to spray before egg laying occurs. After the first eggs are found, no further fly sexing or detection of egg development is necessary to determine the first treatment timing, but fly monitoring should continue. This is the latest information available for helping growers accurately time sprays and reduce the number of spray applications. The easiest way to determine the sex of flies is to remove each fly from the trap and place them on an index card. Some growers find a dark color card provides a better background for finding eggs. The female is slightly larger than the male and has a pointed abdomen with an ovipositor. The first leg segment on the female fly is blonde or yellow, while the first leg segment on the male fly is much darker and brown to black. This is easy to see with the 10x powered hand lens. Then you can proceed to press on the female's abdomen with a pointed object or a knife blade tip until the contents of the abdomen are squeezed out. If the females have eggs, you will see the pearly white eggs that look like small grains of rice. The typical treatment program for walnut husk fly is to continually control adults during flight using multiple applications. Growers that use this approach often start spraying at the beginning of the flight and continue spraying every 2 weeks through the entire flight, and may put on 4 or more sprays. This approach is not only expensive, but detrimental to integrated pest management principles. Sprays that have been applied too early will have little effect, and considerable damage can occur even with multiple, poorly timed sprays. The IPM strategy for controlling walnut husk fly calls for the prevention of egg laying and requires only 1 or 2 applications. With this approach, knowing when egg laying is about to occur is the key element in determining spray timing. Using this strategy, once the first eggs are found in females, growers will have up to a week to spray before egg laying starts, and early punctures or stings can be seen in the orchard. This spray timing may be as early as late June in coastal areas, but it is usually early to mid-August in valley locations. This approach is economical, and it enhances IPM principles by often requiring only 1 treatment per season. Egg development in flies is not temperature dependent and will not be the same in all orchards. This makes it important to monitor and treat each orchard for walnut husk fly independently of what happens in neighboring orchards. For control, an insecticide in combination with a protein bait to attract the flies to the insecticide is recommended. With this combination, treating every other tree row is sufficient for control. An insecticide and bait combination is more effective, more economical, can be more rapidly applied, and is less disruptive to beneficial insects than full coverage treatments applied without bait. Aerial applications are effective when bait is used and timing is accurate. Remember, when using baits, coverage is not as important as with other pest sprays. Using a handgun with spot treatments containing bait has also been successful. It is important to use large droplet sizes for better control of the walnut husk fly. It is common to continue to catch a few flies on the traps after a treatment is applied. This is particularly true in traps placed low in the tree, because flies reach the trap before coming in contact with the spray residue. If the infestation occurred early, you may have to spray a second time, 3 to 4 weeks later, when the residue runs out and there is a sharp increase in trap catches on traps placed high in the canopy. Monitoring again for the presence of eggs in female flies will provide accurate spray timing information for this second application. Once eggs are detected, a treatment should be applied within a week. However, treatment is not necessary within 3 weeks of harvest or after the husks have begun to split. The information provided in this videotape program is the most current research-based information available on using IPM strategies to control walnut husk fly. To summarize the information presented in this videotape program, the following are some commonly asked questions about walnut husk fly and the answers. What is the preferred trap to use to monitor walnut husk fly? The preferred trap is the yellow sticky panel coated with unbaited stickum with an ammonium carbonate supercharger attached. When should traps be placed in the orchard? Traps should be placed by May 15th in coastal areas and by July 1st in valley locations. How many traps should be used? Always use more than 1 trap per orchard. 2 traps per 10 acres placed in hot spots should be adequate. Where are these hot spots? Trees suspected of being hot spots for walnut husk fly include large shaded trees, trees in damp areas, those near black walnut trees, and trees that were damaged by walnut husk fly in previous years. Where should the traps be placed in the tree? Traps should be placed on the north side of the tree, 2/3 of the way up and amongst the foliage. How often should traps be monitored? Monitoring should occur twice a week as a minimum. 3 times a week is better to avoid damage before the first treatment is applied. After the first treatment is applied, once per week should be adequate. What is the treatment threshold for number of flies caught? There is no treatment threshold based on fly catch. If flies are caught, it indicates a husk fly population in the orchard. If there is an increase in fly catch, this indicates an increased emergence. Since flies can be in the orchard for several weeks without causing damage, fly catch should not be used as the treatment timing tool. Then what is a better treatment timing tool? The presence of eggs in female flies indicates it is time to treat. This approach will allow you to apply your pesticide before damage will occur without treating too early before it is warranted. Can I use day degrees to time sprays? No. Husk fly development is not driven by temperature. This is why fly catch and treatment timing is different in neighboring orchards and should be monitored independently of one another. After treating for husk fly, I still catch flies. Does this mean my treatment failed? No. The traps are very good attractants and will continue to catch some newly emerged flies before they come in contact with the treatment residue. This is particularly true if the traps are placed low in the tree. Since there is only 1 generation per year, does this mean I need to treat only once per year? Not necessarily. There is only 1 generation, but emergence may occur over many weeks. You need to consider how long your spray residue will last and if fly catch increases. If you begin catching large number of flies on traps placed high in the tree canopy and you are more than 3 weeks from harvest, an additional treatment may be necessary. A second treatment, if necessary, is usually applied 3 to 4 weeks after the first treatment, depending on insecticide residue, increase in trap catch, and the presence of eggs in female flies. How long will short residual insecticides plus bait kill walnut husk fly? They should kill husk flies for 10 days. With the egg development period included, you should have 3 weeks protection between applications. If I use a bait, will I continue to attract husk flies to my trees after my insecticide residue runs out? No. The attractant fades before the insecticide toxicity ends. Are aerial applications effective? Yes, if bait is used and timing is accurate. When using baits, coverage is not as important as with other pest sprays. For answers to other questions about walnut husk fly, please contact your local University of California Cooperative Extension office.